Welcome to Start Pencil. This class will discuss about some of the applications of trigonometry. That is mostly distances and heights. Let's discuss about line of sight, angle of elevation and angle of depression. Okay. So in this left side, this picture, a boy is standing here and he is looking at the top of the tree. So the top of the tree is assigned as a B point. Okay. So he is looking at the B point. Okay. The line joining between the boy's eye and the top of the tree is called the line of sight. Okay. So the straight line going from the eye of the boy to the top of the tree is called the line of sight. So he is looking at the elevated object. That's the reason this is called the angle of elevation. Here theta we are calling like the angle of elevation. Okay, if you see the right side picture, the boy is sitting at the top of the tree and is looking down the object. Here the object is the car. Okay, he's looking at the car. Okay, so whichever the angle is looking, okay, that we are calling angle of depression. So what will happen this angle of depression when this object is coming closer to the object? Okay, it's keep increasing the angle. Okay, so right now this is the angle. When it moves somewhat closer to the tree, okay, then this angle will be keep increasing. When it is approached to the angle to the bottom of the tree, this angle will become the 90 degrees directly, right? Similarly, what happens this angle when boy is approaching to the tree, okay? When he is approaching to the tree, this angle will be keep increasing, okay? So now we learn about the line of sight. Line of sight is the user eye to the object. If you join a line, that line is called the line of sight, okay? When user is looking at the elevated object, the angle between the line of sight and the horizontal is called the angle of elevation, okay? And if user at the top and he is looking at the downside object, and the angle between the line of sight and the horizontal is called angle of depression, okay? Clear, right? Before solving the actual problems, let's see why it is tan 45 is equal to 1 and tan 30 is 1 by root 3. So how these numbers comes from, okay? Let's see, okay, this is the horizontal line. I'm keep increasing the angle from this first point, okay? Let's take this the one angle. Let's take this the 30 degrees angle. Okay, let's take some angle, okay? So there are the two lines I have drawn from a single point A, okay? This is the horizontal line and I have drawn another line with a 30 degrees angle, okay? If you draw vertical lines, okay, at various points, here I draw one vertical line, sorry. Here I draw another vertical line. Here we draw one vertical line, okay? B, C, D, E, F, G, okay? Let's assume you have set right vertical line, this will become the 90 degrees in all the lines, right? Okay, ABC is one triangle and ADE is another triangle and APG is the another triangle, right? So this vertical height, let's take here let's take this is Y1 height and this is take Y2 height and this one take Y3, okay? Similarly, let's take the distance from the A point, that is this is X1 and this is X2 and this is X3, okay? Let's take any degree, like, I just taken the example for 30 degrees. Take any fixed angle, okay? So here angle is fixed. We are not changing the angle and we draw the perpendicular line to the horizontal at many places, okay? So it forms the right angle at the CEG, okay? So it forms the many triangles, okay? Now we observed some specific relation between the Y and X's, right? Let's see Y1 by X1 if we calculate it, and if we calculate Y2 by X2, similarly if we calculate Y3 by X3, it seems to be very constant, okay? We are seeing a single number, okay? That number may be 0.1, 1, 2, 3, 3.5, 4, 4.5, like anything. We got single number, if you see these ratios, like y1 by x1, y2 by x2, y3 by x3, like that. So we are seeing some constant. Okay. So let's find that constant. Let's assume that. So we'll find that constant like that we thought. Okay. So let's find that constant. Okay. Graph paper, in the graph paper, you can draw this line, and using the protractor, you can draw 30 degrees line and keep drawing the vertical lines. Okay. Then you take any of the y and x ratios. Okay. Any of the y and x ratios, like y1 by x1 or y2 by x2 or y3 by x3, you are getting some number, right? For example, if you draw a vertical line, this measuring is equal to 1 centimeter or 1 meter or 1 unit, okay? If you draw it 1 unit, then you are seeing the x1 is equal to root 3, okay? So this relation is going, the ratio, if you take y1 by x1 here, it is a 1 by root 3. So it is a some number, okay? When you draw any number of lines like that, you are seeing this constant same, okay? So if these ratios are constant like 1 by root 3, okay, can you relate this one with theta, to the angle? Okay, we are measuring with degrees right angle. So to make some relation between this angle and this one, they introduce the term like, right, tan, right? Like tan theta, if it is 1 by root 3, you think that this angle is automatically it's a 30 degrees, okay? Okay. Similarly, if you draw this graph for the 45 degree, right? So when you calculated that time, the ratios like y1 by x1 or y2 by x2, you are seeing very constant and seeing the number 1, right? So they define the 1 is corresponding to angle 45. Okay, so tan 45 is become the 1. Let us see some problems. Okay, so first read out the problem here. So an observer 1.5 meters tall. Okay, so the height of the observer is 1.5 meters and is 28.5 meters away from the chimney. There is a chimney is there. So he's just standing at 28.5 meters away from it. Okay, so the angle of elevation is 45 degrees from his height to the tip of the chimney, right? Then what is the height of the chimney? Okay, so just ask the height of the chimney here. So you need to write whatever is given. Let's draw a diagram, okay, to understand better. Okay, there is a chimney. Let's take this is the chimney. And this is the ground, okay? This is the ground. Okay, this is a chimney. And an observer is standing here, okay? Let's draw an observer, okay? So is the observer having head, okay? I am poor at drawing, okay? So he's just looking at the top of the chimney, right? So there's a line, okay? This is a line, top of the chimney. So what do you call this? It's called the line of sight, okay? Line of sight, okay? So at what angle is looking at elevation angle? So angle of elevation is 45 degrees. If you draw another line parallel to it, so he is given the elevation angle is 45 degrees here. Okay, let's note down the points here, something like that. Okay, A, B, C, D, and E. Okay, where it touches. So here it is forming the right angle for this, right? And here also the right angle. Okay. Now what he asked for it? So he has given another thing. Okay, the height of the observer is 1.5 meters. So here BC is the height of the observer. So BC is the height of the observer, that is equal to 1.5 meters, right? Then what else is given? So the observer is just standing 28 meters away from the chimney. So this is he is standing here. Here is the chimney. So distance CD or BE both will be 28.5 meters, right? 28.5 meters. This is 1.5 meters. Okay, so here CD is equal to 28.5 meters or BE also 28.5 meters, right? So now what he asked you, height of the chimney. What is the height of the chimney? AD is the height of the chimney. Okay. So AD is height of the chimney. Okay. So also you can write AD by splitting to the user height and AE, right? So we can write AE plus ED. Okay. Here ED is same as user height like BC, right? So it is AE plus BC. Okay. So we need to find the height of the chimney here, right? So let's take the triangle. Let's take the triangle ABE. Okay. And if you take the tan 45, okay, what is tan 45? Let's take tan 45, okay. So tan 45 is opposite side by adjacent side, right? So what is the opposite side? AE, and adjacent side is 28 point. So BE, okay. BE is equal to CD, like that, right? So if you put it here, it is AE by BE, okay. So what is tan 45? Tan 45 is the one that is equal to AE by, okay. Here what is the BE? 28.5. So AE is equal to 28.5. Okay. Then what is the height of the chimney is AD, right? So AD is equal to, we know that it is a sum of these two, right? AE plus ED, right? Okay, so AE is how much? 28.5 plus height of the user. This is the height of the user or observer, okay? It is 1.5. We sum up this one, we get 30 meters, right? So height of the chimney is 30 meters. How beautiful to solve this problem. See, instead of measuring the pole height, okay, user can stand at a distance from the pole and just using the protractor, you can find out the angle of the top, okay, that we are talking, line of sight. Then you can draw the triangles, okay, simple using the tan 45 here. Then we can find the height of the pole, okay. Let us take another problem. Here, the shadow of the tower standing on a level ground, okay, is found to be 40 meters longer when sun altitude is 30 degrees than when it is 60 degrees. Okay, find the height of the tower, okay. Let's draw a tower, okay, here. So let's take this EAB as the pole, okay. Okay, pole or tower, okay. Tower when sun is coming from this side, okay. So that there is a shadow is coming on this. Let's take on this side. There's a shadow is coming, okay. When sun is at height, the shadow will be less, right? When it is just in the lower side, the shadow will be more, okay. You can see actually in the early morning, the shadow will be much longer, okay, because the sun is here. If the sun is here, there is a lot of shadow will be coming on the other side. When sun is going to the up and means like 60 degrees or 90 degrees, and the shadow will be keep decreasing, okay. So what he has given, let's draw two lines, okay. Okay, so now we have drawn a shadow of the sun, okay. So when sun is this side, so we are seeing the shadow. So when it is the 60 degrees, okay, and when it is 30 degrees, okay. Now we have drawn the diagram as per the problem, okay. So when sun is at 60 degree, the point is closer to the tower, okay, because the shadow will be very less. That means we can see actually in the mid of the day, right, where like 90 degrees sun at the mid, so we don't see any shadow, okay. But either sun is going this side, we'll get the shadow this side, but sun is this side, we'll get the shadow this side. But when it is at 60 degrees angle, the shadow is of this tower is BC, okay? But when it is 30 degrees, means much closer to the horizontal, that means it is 30 degree. We are seeing the shadow of the tower is falling at the point D, okay? So what is given when observed at the 30 degrees angle and 60 degrees angle, the shadow is observed is 40 meters is observed. So, okay, the distance between C and D is 40 meters. This is what the given in the problem, right? So this is the data we need to enter actually. First, whatever is given, okay? So we entered all the data, whatever is given. Now what we need to find? We need to find the height of the tower. That is AB we need to find out, okay? So always I say, right, we need to assign a arbitrary we need to assign a alphabet whichever we do not know, okay? Then later we'll reveal with that one. So height of the tower we do not know. Let's take the height of the tower is H, okay? And when at 60 degrees angle the shadow is X, right? Let's take the X because we do not know that. We do not know, right, this one, okay? But when angle is 30 degrees sun, we know the shadow. That shadow is this total distance, that is X plus 40, right? Okay. Now we use these simple triangles like, tan 30 and tan 60, okay? I'm writing here first tan 60. What is tan 60? Opposite side AB by adjacent side CB, right? So what is the AB we have taken? We have taken the height of the tower, right? Divided by X also we do not know. So we are just keeping the X. Because BC we have taken the X distance, right? What is the tan 60? Okay, we know that tan 60 is root 3, right? So it's root 3. So we have one relation, that is H is equal to root 3x, okay? Check another triangle, that is A, B, D, okay? If you take this triangle, let's write tan 30 here, okay? From this, what is tan 30? Opposite side AB by BD, right? Okay, right. BD, right? So, what is the AB? AB is the height of the tower H. Divided by what is the BD? It is the sum of the X and 40. So, it is X plus 40, right? So, what is tan 30? Tan 30 is 1 by root 3. Okay, 1 by root 3 is equal to H by X plus 40, right? So, let's simplify this equation. So, here root 3 into H is equal to X plus 40, okay? So, H is equal to 1 by root 3 into X plus 40, right? So, okay. So, let's rewrite this same thing here, okay? What is H is equal to 1 by root 3 into X plus 40? We know X, right? From this equation, X is equal to H by root 3, right? So, let's write H is equal to 1 by root 3 into, what is the X? H by root 3, right? Plus 40. So, if we simplify this one, so H by 3 plus 40 by root 3. So, bring the left side H by 3. So, we can get, I'm rewriting here. So, if you bring the left side of this one, so H minus H by 3 is equal to 40 by root 3. Okay, then this is, if we just take the LCM here 3, we will get like 3H minus H is 2H by 3 is equal to 40 by root 3. Okay, so H is equal to 3 by 2 into 40 by root 3. So height of the tower is 20. 3 by root 3 is root 3, right? So 20 root 3 meters. So now we just use the two triangles and the tan 60 and tan 30. We found the height of the tower, right? We'll see the last example for this session here. So here is a straight highway leads to the foot of the tower. Okay. So there is a tower. There is a straight highway is going to the foot of the tower. Okay. So a man standing at the top of the tower and observed a car is at an angle of depression 30 degrees. Okay. So the person is seeing the top of the tower and seeing the car at a depression angle of 30 degrees. Okay. Which is approaching to the foot of the tower with uniform speed. Okay. So here is given car is moving with uniform speed. Okay. 6 seconds later. Okay. After 6 seconds, the car angle has been changed to the 60 degrees. Okay. Then we need to find the how much time is taken to reach the tower from the point where the 60 degrees you have seen, right? From that point, we need to find that. Okay. The question is clear, right? So I draw the diagram. Let's take these points. Let's take the height of the whatever they is selling, right? As a tower, right? Is selling. This is the height. Okay. So this is the road. Okay. So this is the car. Okay. So this car is approaching to the point B. Okay. There is a straight highway is going to the foot of this tower. Okay. So end of the road is the tower bottom. Okay. So the car is here. Okay. User is sitting at the A. Okay. Top of the tower. User is sitting. Okay. User or what we are calling the observer. Okay. Sitting at here. Okay. First time. So what we are calling here this angle of depression, right? So when car is here, the observer observed that angle of depression is 30 degrees. So this is 30 degrees is given. Okay. So that is also equal to this angle of 30 degrees, right? So let's take this point C and this point D. Okay. So when initially the observer see the car, that the angle of depression is 30 degrees and the car is located at the point C. Okay. After 6 seconds, the user observed the car is moved to the point D in 6 seconds. So C to D, the time is taken is 6 seconds. Then the angle of depression is changed to 60 degrees. So this angle is changed to 60 degrees, right? So that is also equal to this angle. So 60 degrees. So the time taken to travel from the point C to point D taken 6 seconds and the angle of depression changed from 30 degrees to 60 degrees. Then what he asked for? He asked the find time taken to reach the foot of the car. Okay. What is the time to take D to B from this point means from the D. Okay. How much time it will be taking? Okay. So we need to find the time. So before starting and the actual problem, let's see what is the speed. Okay. Speed is distance traveled to the time, right? Distance divided by time. Okay. So when you see in the bus is going with 60 kilometers per hour, that means 1 hour the bus will be going to the 60 kilometers distance. That's why we are representing the speed or velocity with the kilometers or kilometers per hour or meters per second, like that. Okay. So if we given the units is meters per second, that means for 1 second it is going to so many meters distance. So he has given the constant speed. Okay. That means he is not changing the speed when it's starting from the C to B. Okay. When started at the C point D, he has not changed the speed. He's going with the constant speed. Okay. With that condition, we need to find the how much time is taken to travel between the point D and point B. So user observed initially the car is located at the point C. Okay. So let's calculate the speed when it is traveling from the point C to point D. Okay. So whichever the distance we do not know, let's take with some CD is some X. Okay. X is the distance and the dV is the Y is the distance and the height of the tower is H. Okay. So here CD is the X is the distance traveled and the dV is the Y is the distance and the time take for the Y distance travel is let's take is a T, small t you have taken. Okay, right? Now, how do we calculate the speed speed can be calculated. Speed is equal to distance traveled to the time, right? So distance traveled to the time. Okay. So let's calculate the speed when this is traveling from the point C to point D. How much distance he covered? He covered the x distance, right? And what is the time he has taken? The time is 6 seconds time has taken. Okay. So it is x by 6. So let's calculate the same speed when he is traveling from the point D to point B. Okay. So the distance he covered is y divided by, what is the time? Time also we do not know. So let's take time is t. So he is saying that the vehicle is going to the constant speed. Speed is not varying. That's why we will equal this equation number 1 and this equation number 2 will make it equalate. Okay. So that it will become x by 6 is equal to y by t. Okay. So here let's write here like x by y is equal to 6 by t, right? So this is the one equation. Let's take this another equation number 3. Let's take the triangle ABC. Okay. From this triangle, if you write tan 30 is equal to, what is the opposite side? AB by adjacent side is the BC, right? What is the AB? AB is the height of the tower, h by adjacent side is the BC, that is x plus y, right? Similarly, if you write another triangle with ABD, okay, if you write with this triangle, then you can write the tan 60 is equal to, is also h by y, right? This is the only distance between B and D is the y, okay, so h by y. So from these two equations, if you keep the h's, h if you eliminate it, okay, let's take from this first equation, h is equal to, okay, x plus y into tan 30, right? And same equal to, if you from the another equation, what is the h is equal to y into tan 60, right? Y into tan 60, right? Okay. So here x plus y into, what is tan 30? 1 by root 3 is equal to y into, what is the tan 60? Root 3, right? From here, if you root 3 taken to other side, this is x plus y is equal to 3y, right? I am continuing to write from here, okay? So this expression is x plus y is equal to 3y, right? If you take x is one side, x is equal to 3y minus y, okay? So x is equal to 2y. So if you bring the y this side, so it's x by y is equal to 2, okay? Let's take this is equation number 4. So if you substitute equation number 4 into equation number 3, okay? So if you put x by y as a 2 here, so what is the equation number 3? X by y is equal to 6 by t, okay? So what is x by y is 2, right? 2 is equal to 6 by t, okay? T is equal to 6 by 2, that is equal to 3, okay? So t is equal to 3 seconds. So time taken to travel the car from the point D to foot of the tower is 3 seconds. Okay, that's the answer for the problem. Okay, thank you for watching. Okay, if you like the video, please press the like button and subscribe my channel and share with your friends. Thank you.